every couple of months, it seems like there's a new headline about nuclear fusion. Some new discovery that's going to change everything. Last year, it was the announcement that scientists had reached ignition. This year, it's news of a net gain in energy, meaning the team behind. The experiment said that their device produced a fusion reaction that generated more energy than the amount required to trigger the reaction in the first place. So close, so near. Are we finally on the verge of unlimited clean energy? Well, maybe. But before you start tearing up your lawn to make room for a backyard fusion reactor, here's what you need to know. Let us be clear. The recent results from the National Ignition Facility at the Lawrence Livermore National Laboratory are remarkable. Scientists were able to achieve a fusion reaction that yielded 3.15 megajoules of energy. The laser system used to trigger the reaction took about 100 kilojoules. So put simply, the energy yield exceeded the input by more than 30 times. The achievement was hailed by some as a milestone, a triumph of science. And it is all of that. But it's also, above all else, a demonstration of a scientific principle. Something entirely different from actually harnessing that principle to power our homes and cities. That's engineering, and it's a very, very different ballgame. To see why, let's go back to the basics. A nuclear fusion reaction occurs when two light atomic nuclei combine to form one heavier nucleus. You've probably heard that this is how stars generate energy. What you probably didn't realize is that this process requires enormous pressure and temperature to occur. The Sun, for example, maintains core temperatures of roughly 15 million degrees Celsius. To achieve this on Earth, scientists use lasers or particle beams to heat and compress a small amount of fuel, triggering a fusion reaction. The resulting explosion lasts less than a second, but it produces enough energy to power a household for several days. Now, since the 1950s, scientists have been trying to replicate this process in a lab. The goal is eventually to create a reactor that can generate more energy than it consumes. This is called net energy gain. Since the process uses nuclear fuel, it's known as nuclear fusion. Most people think of fusion as a promising alternative to fossil fuels, which release harmful gases into the atmosphere. Fusion, on the other hand, produces much smaller amounts of greenhouse gases and pollutants, making it a very attractive option. Plus, unlike fossil fuels, it has almost limitless potential. It's important to remember that we already use nuclear power extensively. As of 2022, 10% of the world's electricity came from nuclear sources, either fission, splitting atoms, or fusion, combining them. Fission reactors have been in operation for decades. Fusion reactors, on the other hand, are still in the experimental stage. But in the last few years, things have started to get really exciting. In 2021, a group of researchers announced that they had achieved ignition for the first time. This meant that the reaction produced more energy than the amount required to trigger the reaction in the first place. The recent experiment took this a step further. For the first time, researchers were able to show that a fusion reaction could produce a net gain in energy, meaning that the total amount of energy produced exceeded the total amount consumed during the reaction. The reason this is such a big deal is that it is the key to producing net zero carbon emissions. If you have a reactor that generates more energy than it consumes, then you've cracked the code to producing energy that's truly sustainable. It's essentially limitless. All you need to keep the reactor running is the initial input of energy required to trigger the reaction, In theory, that is. Now let us talk about realities, because these experiments are far from being the same thing as having a working fusion reactor. For one thing, the experiments only last for a fraction of a second. While the energy output may be astounding, the reactor itself is only operational for a brief period of time. Secondly, the amount of energy produced is minuscule compared to the amount needed to power our homes and cities. To generate enough power to run a single household, a fusion reactor would need to maintain its reactions for several hours, not just fractions of a second. Researchers are nowhere near achieving this level of control and consistency. Thirdly, these experiments require massive inputs of energy both to trigger the reaction and to contain it. For example, the National Ignition Facility at the Lawrence Livermore National Laboratory, which achieved the latest breakthrough, uses 180 lasers to heat and compress the fuel. These lasers require an enormous amount of energy to operate. Drawing power from a massive facility that sprawls across 10 acres, and then there's the issue of scale. A typical power plant generates enough electricity to power hundreds of thousands of homes. A fusion reactor would need to generate at least this much power to be economically viable. But to achieve this level of output, researchers would need to increase the size of the reactor by orders of magnitude. This presents numerous technical challenges, especially in terms of containing the reaction. Finally, fusion reactors produce radioactive waste products that need to be carefully managed. This is less of a concern than with fission reactors, but it's still an issue nonetheless. So, that's the bad news. But before you throw your hands up in defeat, let's talk about why all of this is still really important. One of the biggest challenges in developing new technologies is that there is often a significant gap between a scientific breakthrough and its practical application. Take solar cells, for example. They were invented in the 19th century, but it wasn't until the late 20th century that they became commercially viable, despite the gap between invention and application. It is crucial to continue investing in research and development because we never know what breakthroughs are just around the corner. Take, for example, the recent developments in quantum computing. Just a few years ago, experts believed that it would take decades to develop a quantum computer capable of performing a meaningful calculation. Yet, in 2022, Google announced that its quantum computer had successfully solved a problem that would have taken a conventional supercomputer thousands of years to solve. This breakthrough highlights the importance of investing in basic research. We may not know exactly where it will lead, but we can be sure that the breakthroughs will be significant. In the case of nuclear fusion, even though there is a huge gap between the current state of the art and the development of a commercially viable power plant, it's still worth pursuing. The potential benefits are too great to ignore. The bottom line is that we need to continue investing in science, even if we're not sure where it will lead. The payoff could be enormous. Let's not forget that these breakthroughs don't happen in a vacuum. They're usually the result of a long process of trial and error, refinement and iteration. In the case of nuclear fusion, scientists have been working on this for decades. The recent breakthroughs wouldn't have been possible without the work of countless researchers and engineers who came before them. Likewise, the breakthroughs of the future will depend on the work of the scientists and engineers of today. So, what should you take away from all of this? First, it's important to be aware of the difference between a scientific breakthrough and a technological innovation. A scientific breakthrough is a new discovery or finding that advances our understanding of the world. A technological innovation, on the other hand, is the practical application of that discovery. For example, discovering that a fusion reaction can produce a net gain in energy is a scientific breakthrough. Developing a commercially viable fusion reactor that can provide a reliable source of energy is a technological innovation. Second, don't lose sight of the bigger picture. While it's easy to get caught up in the latest headlines, it's important to remember that scientific progress is a gradual process. Breakthroughs do and happen overnight, and it is often the small incremental changes that lead to the most significant advancements. Finally, keep in mind that the pace of technological change is accelerating. Developments in artificial intelligence, gene editing, and other fields are happening at an unprecedented rate. This means that the skills and knowledge you learn today will be even more valuable tomorrow. One of the best ways to stay ahead of the curve is to invest in your own education and development. That's where Brilliant comes in. With Brilliant, you can learn more effectively and efficiently than ever before. Their interactive courses make learning fun and engaging, which is key to retaining what you learn. Whether you want to brush up on your math skills, learn more about artificial intelligence, or anything in between, Brilliant has you covered. Their library of online courses covers a wide range of topics in science, computer science, and math. No matter what your level of expertise, Brilliant has a course for you. So what are you waiting for? Don't let the future pass you by. Start investing in yourself today.